Right? You see on the top of the surface, it is still working in a triangular fashion. Actually, this is from the STL file, because this geometric model has been created using the STL file. So on the top surface, it is a triangle. And when we generate the toolpath, so again, it is using the STL file. This STL file we will talk in the next session briefly. And here also, whenever you have a query, how it has been done, or what are the tools I have used, you please type in the chat box, because for this 1 hour session, I'm just trying to share the ideas where you can take up your further research or new projects for your MTech and PhDs. Okay, I'm not going into much deeper details at this moment. Right. So this is the hybrid additive subtractive process we have done. This is the deposition, and this is the machining on the same setup, right? So you see this kind of part we can print, and you see if we do not go first setup, this is our desired model. The smooth surface is required, right? So if we go this part by machining, you can machine it proper smoothly, right? But a lot of this material wastage will be there, right? Because this much material you are going to remove. So what we have done, instead of material removal process or subtractive processes, we have used the additive manufacturing to deposit this material. As a result, what happens? You got this kind of stair effect, right? This is the inherent characteristics in the additive manufacturing, because you are printing part in a layer-wise fashion. So this kind of stair effect is coming. So this surface roughness will be very poor and steps will be visible, right? So what we have done is, after this doing addition, we have gone through the subtractive process, and the same setup, same machine, we are able to change this tool, and now we can remove these extra things, right? We will again talk how this extra material has come, right? Very interesting part. So we will do the additive, and we will do here the subtractive process to get the final finished product in such a way. Okay. Now see what we have done with the computational tool. All this, the graphical user interface, you can see this is what we have developed in a material is in which form? Yeah, in this case, material is in the palette form instead of pooled wire form. I'm coming to that. Yeah, very nice, good question. Please, everybody, please keep on typing in such a manner. Okay. So you see on the screen what we have done. This is the toolpath generation for hybrid additive subtractive processes. We have developed this entire graphical user interface in a MATLAB. So we can assign the parameters like road width, layer thickness, deposition speed, the feed rate STL. We can import the STL import. And here you see the button. The behind this screen, the entire MATLAB program is available. And I will show you those MATLAB program in the next lecture, right? So we can STL import, we can do the slicing, we can generate the tool path, and then this tool path we can convert to the G&M code, and then finally file. So you see this is the STL file, this is the tool path generated, and sorry, this is the contour generated, and this is the tool path generated on here. So contour, one contour, second contour, inside is the raster filling. Okay, so in this, now look at this, what we have done. This is the toolpath generation, G&M code for deposition up to this part, right? Now here we have used the subtractor. So here what we have done, cutter diameter, step over, then again generate the toolpath, GMN code, and show the file. So here what happened, this is the part you have already printed. On this part you have done the machining in this form, right? So this is the machining. Here what is happening, this process is done from bottom to top. Here this process is done top to bottom, right? And in the bottom, you can see again the geometric model, STL file, contour generation, toolpath generation, and you see on the top surface there is two triangles. So what is happening, because I am using the STL file to generate the toolpath, that's why it is working in a triangle fashion. So this is one triangle, second triangle like this, and that is the reason on the top surface while we showing you the machining video, you found there was a triangle like this. See in this case again on the top surface you will find the different triangles are there, right? So this is working in a triangular manner. One triangle, second triangle like this. Let me move ahead. So you see over here, this is moving in again in a triangular fashion, right? Because on the top surface, due to STL file, you have the triangle. So it is taking one surface, one top triangle at one time and machining it, right? So we are also working on getting the higher order polygons to avoid this situation and use the process more effectively. That we will come little later. Okay. Now see, because in this entire process we have used this hopper, right? You can see over here in this hopper instead of wire for material we use the pellet form. Once we are using the pellet form material, we are having the added advantage. We are not at all worried about the buckling of the wire material or the spool material, right? So what happens, instead of we have put into the pellet form, and once we go through the pellet form, the lot of challenges are there, right? Like you see here, the voids are there, like synchronization not done, then the material flow is higher than the nozzle. So this type of overlapping occurs. See here the road width. So again, there is a void, right? The gap, the porosity will come, because what happens, the speed of the CNC nozzle or deposition tool is higher than the material flow. So lot of synchronization we have to achieve in this process. What you seen in the video, that is the final video. So additionally, what it allow us to print some flexible parts, because now you know the EVA material, right? ये जो जूते चप्पल हम बनाते, right? So shoe soles we use using the EVA material, the sleeper, very flexible material, rubber like material that cannot be processed by any triple F process, FDM process, right? Because the material is required in a wired form, and that wired form material has to be pushed, right? So buckling is occurs. But here in this process, this is completely extrusion based process. So any soft material can also be melted, deposited through the deposition tool, and we can have such kind of flexible parts printed through this. Coloring, okay. What you are trying to say using coloring? Here, whatever the color material palettes you can use, the color will come. Anything else you are trying to say? See here on the screen, the flexible parts you can see. These flexible parts you cannot print with any of the commercial material available. Even for the TPU is flexible, but not that much. TPU spool form material is available, right? But the EVA material cannot be printed in a wire form, right? So you see over this can further lead to for the sensors and actuators to be embedded in the part, or wearable electronics on your hand, right? So this lead to the flexible material printing as well. Okay. Now the issue comes is here is that like this material, right? This is the extra material printed. Or here in this case, I have talked about this kind of extra material is printed. So somewhere it may be extra material, somewhere it may be a less material, right? Because once we do the slicing, I hope the slicing is clear to you. Say, for example, we have this kind of part, right? And we will do the slicing like this. Okay. And when after this slicing, when you extrude the deposit the layer, the situation will be like this. This will be the deposited part. So you see here, there is a less material, right? Similarly, on the top side, if you see here, if you extrude it, this feature, it will go like this, right? Sorry. So what happens here is the extra material, right? These two situations will come over here. So there are different situations in the shape deviation, right? So you see here, if this is the case, your part will look like this, right? This stairs will come. This is representing one layer. If you do in this direction, then also you will have this kind of stair effect, right? So what you can do here? Say this is the shape. Okay, so suppose we start with the bottom up slicing processes, means from bottom to top, right? What you are going to do, you will start like this slicing. Second layer, third layer, fourth layer, fifth layer, top layer. Now, can you notice what has happened? On the bottom side here, the less material. This is the desired geometry, and you have done this slicing. So you have got this contour by cross section and extruded it in the top, right? So what happens here? You have the less material. And on the upper side, what is happening? You are getting the extra material, right? So how to know where is the extra material, where is the less material when you go for the part printing, and then you take up to the same on the same hybrid additive and subtractive process system to remove the material. Okay. See another approach. If suppose we go with the top down approach, right? So we are coming with the top down approach. Means we are doing slicing from the top to bottom. Once you see the top to bottom slicing we will do, you are getting the contour and then extruding it towards the bottom side. See what happens. In this case, situation has reversed. You are getting the less material on the top side and the extra material on the bottom side, right? But both are the situation not at all solving our problem, right? What we want something that this either this material less throughout the part so that you can do some additional polishing or depositing more material on the fabricated parts. Either you have the extra material throughout the part. So what you can do the machining processes like this hybrid processes I have shown to remove the material. Or another approach we have adopted, that this is the selective melting processes. So where you can take the heated tool and melt the material which is extra. So that can be done, right? So you see here in the center, this yellow color where there is no extrusion, the flat vertical wall is there, no issue, right? Material is sufficient. Now see the another process, the combined slicing process. Means we can start from the top as well, we can start from the bottom as well. Look at this, what is happening in this case is starting from the bottom. At the center, we have reversed the process. Got half of the portion we have sliced from the bottom to up, and the half of the portion we have sliced from the top to bottom. Now, do you think that the lot of computations is required here? Because this is the visible, right? We are seeing on the screen. When it comes to the computer operations, everything is in binary, 0 and 1. Then you should detect the geometry, what kind of geometry you have, and from where to start the slicing, right? Similarly, you see here, we can also adopt for the extra material. This is you have taken the less material around the part. Now see extra material around the part. So you start in this and from the bottom. What happens in this case? You have the less material across the part. Here you have the extra material across the part. So you can do the machining this extra material, right? Or you can do the selective melting and you can get, right? But this is not the end of the story. You see here, this is the ideal part, I can say, right? Every part will not be like that. So there is possibility of having the mixed situation as well. Means on one side you have the extra material, one side you have the less material. Look at in this situation, this geometric model we have created in the SolidWorks. And you see, once we go for the slicing procedure, this is the process simulation. You can also see this part will look like this. Now, once we do the slicing, right? So once we do this slicing, what is happening? This is the oversized contour, undersized contour, equal size contour, and the new thing is come is the mixed size contour. What is this mixed size contour is? Means one side you have the extra material and one side you have the less material. Look at its front view. See, what is happening? This situation, mixed size contour, right? In this portion, what is happening? Here the less material will come, and on this side extra material will come. Here the less material will come. Here is the equal size contour. On the top you can see it is the oversized contour. It is also oversized contour. And here on this it will be a less size contour, right? See, look at this. So what we have done to avoid this mixed type situation as well. See, this is the example of two layers. You see the first layer I have taken. What happened to the first layer and second layer? This is the mixed type situation. See here, this is here the extra material. Here is the less material. Okay. Here is the extra material, here is the less material. Now suppose you want to run your hybrid system, how your hybrid system, CNC system will understand that this side he has to do the machining and this side he has to put the extra material, right? So this situation is not at all acceptable, right? So what we have to do convert this mixed type situation into some solution where we can. So see what we have done, this first contour, second contour. Okay. Now what we have done, we have taken both the contours C1 and C2, right? This is the C1 contour and this is the C2 contour, right? And what we have done over here, we have merged both the contours, means this is the layer 1 and next is the layer 2. So we have layer 1 and layer 2, we have joined. This layer 1 and layer 2 we have joined and then we have extruded. So see the result is this side also oversized, this side also oversized. I understand you know the Boolean operations. Anyone? Quick answer. Yeah, Vinay Singh. Yeah. So Boolean operations, you know. So you have this contour on the layer number 1 and this contour on the layer number 2. Very fine. Right? So what we have done, we have merged both these contours over here, overlapping these two contours and find out a new polygon of this size, right? After making Boolean operation of this and this, you got this, and then you are using this polygon to extrude it. So that's why you are getting this situation. Both sides you have the extra material. So what we have done for the hybrid additive subtractive process is, this is the subsequent part which is required to extract the advantage of developing the hybrid additive subtractive processes, right? See, this is leading to your process simulation as well. This we have done, we have written a macro in SolidWorks, right? So this is the part you have, this is the equal size deposition layers, mixed size and undersize, and this is here the oversized situation, right? So you can see over here, this is the extra material. Right? I hope you can see on the screen. Okay. So look at this here, this side, less material, this side, extra material is coming, right? Mixed type situation is occurring in between this, right? So we have to find out the solution for this. The algo I have already discussed, right? How we are implementing, we have taken it to the macro and sliced the entire geometric model, right? Identified the situation and wherever required, we have merged two layers, perform the Boolean operation and then extrude it. So see here, the result is this. On both the sides, you have got the extra material. Look at this. This was the original situation and see over here. After Boolean operation, here also you got the extra material and here also you got the extra material, right? Similarly, you can see over here the extra material on this side as well as this side. Right? Both sides you got the extra material, that was the objective. So you have got the post-finishing allowance after contour compensation, right? This is the initial upward facing and that is the extruded material. After layer you do after the slicing, you will get this type of contour information, right? So this is the initially downward facing surfaces, and this is the post finishing allows after contour compensation. So what happens? Left side, right side, wherever the mix situation was occurring, the problem was with the both the material, both side mix situation. Now what is happening here? Both side you got the extra materials. Okay. See here, from the mix situation, the part will look like this. Everywhere what has happened, you got the contour information and you have extruded it. So what happens? This entire geometric model has been divided into a small geometric model of a equivalent to each layer. Right? So you can see this is the simulation of the process as well. After this part, additive manufacturing done, this part will look like this. You will got these stair steps. Means actual part printing will be like this. It is not going to be a smooth surface. Here for visualization purpose, we have taken the layer thickness on the higher side, right? But the layer thickness is in a say, for example, 200 micron. So steps of these stairs will be less. Okay. If you have any question, please keep on typing in the chat box, right? So see the end result would be like this. I hope you are aware about the STL file. Can you quickly answer? See on this screen, you have the STL file where all these inclined surfaces are there and the entire surface is divided into the triangle. We will talk on STL file in the next session. Fine, Ravi Kumar, I can note. Yeah. Anybody else? I think at least 5 quick responses would be sufficient. So you understand? See here, this is the two responses. This is in the STL file, and this is, you see here, everything is converted into the small geometric model. Yeah, 3 responses. Very nice. You will really like it in the next session when I show you the MATLAB programming, how to deal with the STL files in the MATLAB and do all these things. What I discussed so far is with the help of MATLAB. Look it over here. What has happened here? Everything was in the triangular format, right? And this is the single solid model, right? What is happening here? Now this has become a 1, 2, 3, 4, 5, 6, 7, n number of solid models are there actually, and every solid model is in a prismatic form. That's why you can see here in the center. See, this is a flat fish, triangular converted, right? Everywhere. Got it? So this is how we have done, and we have got this right done in the achieving uniform finishing allows. Now what is happening everywhere, the extra material is there. You can take it to the hybrid additive subtractive process system and you can run the CNC machine to remove this extra material. You can get this smooth surface like this and you can remove this, right? So and any question at this part, or else I would like to take you to one more interesting example of triangular meshing. Yeah, to take you to the next process we are under development process is the induction heating based additive manufacturing processes, right? So okay, let me come to the induction heating. I will come this example little later since I have already moved to the induction heating based. Okay, so development of induction conduction based metal additive manufacturing processes, right? Coming to this, you see here what we have done. You can see on the left side. This is the entire system we have developed. On the top side, you can see this is the metal wire spool aluminum. We are melting this wire under this vacuum chamber, initially the closed chamber under the 600 degree centigrade temperature, right? And this is the entire in-house developed system. So you see here, this is the induction frequency generator. And this is the using open source Mac 3 software. And this is the entire computer control process, which is controlling this vacuum chamber. Right. Let me show you here some more internal parts of it. See the inside there is an induction coil. This is the induction coil. Right. If you have anywhere any question, you can mark. You can just keep typing, or you can, if you are allowed to unmute. I would prefer to interact also. Okay. Here you can see this is the ball screws. Full CNC setup developed inside. This is the ball screw for horizontal movement, vertical movement, and this is the deposition table. This table is moving upward and downward. This extruder head is fixed over here. Inside the red heated, you can see here, this is the extruder head. Right? From this aluminum material is deposited. Right? Inside this is the mechanism to push the aluminum wire inside this extruder. Here is the extruder head, right? See, this is the extruder head we are using, right? Here is the deposition table or substrate. So this is also on the bottom side. There is a cooling. I will show you the video as well. And see, this is the entire system you can look. Initially, what we have done, we have kept it in an open environment, right? This system. Then this entire system fixed into this closed chamber, right? This is the setup for available. Let me run this video first. See here the deposition of aluminium. You can see here the process seems slow, but you see this is not the plastic wire. It is the aluminum wire around 600 degrees centigrade temperature. It is depositing just like your polymer machine. So you note it down, the existing metal additive manufacturing processes are mostly either the direct energy deposition and they are in the powder based, right? This is in the wire form, just like your polymer FDM process. Okay, let me run another video first. This is the multi-layer sample. I will explain the inside parts there. See this video. That is the inside within the closed chamber I am running, right? Got it? So see here inside also you can see here, this is the substrate. Red heated is showing. This is the insulation plate and this is the water channels we have created to take away this heat. Otherwise, once this is 600 degrees centigrade temperature achieved with induction heating, the entire chamber is become very, very heated, and this can damage the lubrication system of our CNC positioning system. This can affect our ball screws and stepper motors. So that heat has to be taken away. So not only the insulation, but we have to take the water flowing to carry away this heat outside the chamber. So this is a typical design we have done for the printing table as well to take away the heat, right? Now look at this. Uh, Current status is like this. We are able to print such parts that require again the machine, right? This is again, so that's why we are again going back to move our hybrid additive subtractive system. The first I have shown with this developed system. So the solid part is done, but a lot of issues are still there. Oxidation of the part, not flow in the synchronization. You can see here, this part is not printed properly. A lot of breakage inside this. And inside parts also, this is lot of porosity inside this, not completely solid part. Are in the next page, what to do with the overhanging features, how the support structure will come into picture. Okay, so before this, yeah, let me run this as well. Okay, this is one, the deposition going on the top. You can look it on the top, the deposition going on the top. In bottom side, you can see the entire ball screw system. This is we have done just within the closed environment, right? Now look at this. This is the full system. So you can see from this side, this is the within the vacuum chamber. On the top, you can see the deposition is going on. You can see the movement, the deposition is going on. And this is the entire system. So you can see here, this is the full developed system. This is the tool path we have. So you see, the idea is to see why you require the computational tools for the digital transformation of your additive manufacturing processes and developing new processes. Let me go back to this one part I have skipped quickly. I have the 3-4 minutes in this session. This is one very interesting example with the computational techniques. Out of many other things, I have just chosen this. You see here, we are taking the 3D printing of the image. Let me show you. I think yeah. Can you see on my camera? Is there something visible in this image? If you can see this some image, you can type, see this image, engraving. And now look at this image. This is a 3D printed image, right? Can you identify the person in this image? And this is the 3D printed. You see here, this is a 3D printed image. Similarly, other two images I have shown you. Look at this. Three images I have shown you. On this, we have put the black color tape on the back side. So you can see here the green grading color in pitching. So see, this is the yeah, thank you, Brilmore. So see what we have done, the image, right? We have this RGB image. Okay, so you have the red, green, blue, and the black. Then we have converted to grayscale, right? So you know 0 to 255, right? Okay, then image to point cloud conversion. What we have done, this is the grayscale value, which is 0 to 255 at any point on the image. We have used it to for the third dimension. We have elevated it, right? We have given this elevation based on this grayscale value. So this image is converted into a 3D image. Okay. And once it is converted into a 3D image, we have converted it to a STL formation. And then we have generated the nozzle path. That is the fundamental, right? Theory. Or you can say the algorithm, how we are going to do this, right? Now look at this, how we have implemented it. This is the image, RGB image, converted to grayscale, right? Then the image STL created. So this image has become the STL file, and now this is the nozzle path. And that is what we have printed, which I have shown you in the image. Right? So this is another example. A lot many more examples you can do with the computational. The first thing, you should be good in the computational tools, right? What kind of calculation is required, and that calculation cannot be done every time. So you should know how to do the programming, right? So that the recursive calculations you will be able to perform while you maybe some decision making as well. So you are going to apply do loop, while loop. For recursive things, you have to go with the for loop, etc. And then come out with the decision. Okay. So I think we can end this session. If you have any more questions, you can ask right now, or we will take up more questions during the next session, where we will talk more on the programming aspects. Right. So we will take on the more on the programming, everything which I have shown here, how to implement